Hello and welcome. It's time once again to try to fix something, and today on the workbench I'm looking at an old PS4 CUH-1215A that is rather dead, and I will demonstrate. We do have power connected back there and HDMI, but power button does absolutely nothing, and the eject button is broken, so I can't actually test that. But it doesn't do anything when you press the power button, and if I actuate the Blu-ray, nothing. So I think we've got a power supply problem here. So we may have a power supply repair to do. I've got a good one here to swap in there. Let me go ahead and do that, and let's see if the power supply is our only problem. Well, if it isn't our old friend. Alright, I went ahead and took both top and bottom covers off. I didn't have to take the top one off to get, power supply out, but I knew I was going to be disassembling it to clean, so went ahead and did it. Spare supply is in there. And that eject button is busted, you can see. Not much left of it. Let's see if we have any more life now, though. We do. And there's a disk in the drive. Here it's spinning. And that antenna is kind of jacked up, isn't it? Have to see if they've broken the center conductor on it. That happens. Like if you bump this thing much, it breaks the center conductor where it solders onto this tab over here. And you don't have an antenna anymore. Hey, I think we locked. White light. Checking the hard drive. So yeah, she needs a good bath. But we also have to fix that power supply and replace that eject button and take a close look at that antenna. And let's see, well, I can't eject it. Well, I could once it comes up, but just wondering what kind of bonus disc we have. Let's see. I'll figure out what kind of disc it is and I'll let you know. Alright, it finished with its hard drive check and she is up and looking normal. What kind of disc is this in here? Oh, it's going to be GTA 5, isn't it? Yes. Let's just see if it starts playing. Yep, it's GTA 5. Okay, so that's what it is in there. Let's get this power supply inside, see if we can evict some dead roaches and get it working. Alright, we are inside of the workbench. Ready to take a look at this power supply. As soon as I find my Phillips of the appropriate size. Here we are. And once again, please don't do this unless you are familiar with working on high voltages. There are dangerous voltages in here. Oh, gross. Yeah, this is going to have a thorough cleaning. Yeah. That's just lovely. I'll toss that in the bathtub with the rest of the parts. Alright, let's get with it. What is open? What has shorted? Where's my continuity mode? Alrighty. Fuse. Fuse is still shorted. Thank goodness. How about this little? Let me make sure this is visible. This little fusible resistor is open, which is not a surprise, because one of these MOSFETs has shorted most likely. Okay, that one's not shorted. That's the one I would suspect, but there's another one here. Not shorted. Let's take a look at this one right here. Still no shorts. I also don't see any burn marks yet, any scorch marks. Something shorted somewhere. Let's just check. Negative side of this capacitor, which would be the filter, the main filter capacitor here. That one, which is right here. And the other side of that resistor, this resistor, the fusible resistor that is open, is right here, it looks like. So, okay. According to that, there is currently no short. There was a short at one time because it opened that resistor up. No short at the moment. What about on IC31 down here? Which one's pin 1? I think that's pin 1, 2, 3. I think 4 is ground. Yep. 5, 6, 7, 8. No shorts. What is that? Oh, that's the return path for the MOSFET, so that is low impedance. Now here's my resistors. I think it's 2.2s in parallel. Okay, I believe our Zener has gone. Let me zero out this meter so I can get an accurate reading. .2 of an ohm. Yeah, I think our Zener has purchased the ranch, shall we say? Bought the farm. But our MOSFET does not seem to be shorted currently. I'm very surprised by that. But at some point, at least, that MOSFET was forced on fully because it caused a lot of current to go through these resistors right here. Let me maybe look under the microscope. Maybe we can get a better view there. All right, before we look under the microscope, I have done a crudely made drawing here just to show some things. This is what we're going to be looking at. This is just, a very simplified drawing of what's on here in this 5-volt standby circuit. But you have a DAP41 that's driving this MOSFET, which quite often shorts. It doesn't seem to be short in this case, but it would normally drive the gate of it, and then you've got, up here you've got in standby mode in North America, you've got 120 volt AC power, so you get like 170 volts DC coming through that fusible resistor, which is open, 0.16 ohm, into the transformer, and it's being pulsed right here. This thing runs, I believe, at 65 kilohertz. So it's being pulsed, and this is the where the source, where the common comes through. This is the source of the MOSFET, and in that circuit, there's a 2 ohm and a 2.2 ohm in parallel. So roughly 1 ohms if you parallel the two, a little more than 1 ohm. And that's the current sample for this DAP41 IC. And there is a Zener diode on there to limit how much voltage can be developed across there. I'm guessing it's for like initial startup spikes or something, so you don't overdrive this input. It can only take so much, I suppose. And quite often when this MOSFET shorts because of a roach crawling across the the circuit or something, it will burn these resistors, and sometimes pop the Zener too. It'll short the Zener. But in this case, these seem to be fine. You measure a really low resistance, but sometimes people will measure that and think everything's fine because they get like a really low reading. But in this case, I'm getting close to 0 ohms, and it shouldn't be. It should be around 1 ohm, and that tells me this Zener has shorted. And this is a 9.1 volt Zener. I do have these because they're commonly go. So it may be all it got during whatever spike. Because what happened was that roach crawled across something and caused this MOSFET to be turned on hard. Instead of being pulse width modulated at around 65 kilohertz, it was turned on solid. And the current through this goes just up exponentially. And something's got to give. And so that's what I think happened. So we might get away with just replacing this Zener. I think this IC is still good. Nothing reads shorted, and I think the MOSFET's still good. I'd be very lucky. You know, if I was smart, I'd just go ahead and replace the DAP41, the MOSFET, and the Zener, and call it a day, and the resistor up here. But I only have a few of these DAP41s on hand. I've got more ordered, so I'm going to try to see if I can. I'll check it again with the meter just to make sure, but I think it's probably all right. It survived this little catastrophe in here. But this is, just a simplified version of what we're dealing with under the microscope. All right, now that we're looking under the microscope, we can see those two resistors. Like, here's the MOSFET, there's the source, there's the two resistors, and that's their path, their return path to ground. So we get a voltage developed across these two resistors. It should be about a 1 ohm resistance, but we're reading about 1/10 of an ohm, or 0 ohms, something like that. So, and you can see the Zener here that's supposed to limit that voltage, so it limits what hits this IC over here. You can see this continues on through a 1K resistor. There's a capacitor to ground, and we go into pin 3. That's the current sample. So we're going to be very lucky if all we lost was this Zener and that one fusible resistor, that 0.16 ohm resistor. But it could be, because I'm going to change this out, and we'll just see if that's all there is. That's what we'll go with for now. Alright, I have replaced that Zener diode and that fusible resistor, and we're going to see if we've done any good here. Get my ground, get my 5-volt standby over here, and I'm going to bring the voltage up slowly, the input voltage, with my variable transformer over here. See what happens. Ooh, and we had something go smoke. I think it was the MOSFET. Yeah, I can smell it. Yeah, I think our MOSFET was bad, because it kind of went poof. Hope the camera caught that. Okay, so we didn't find everything. So we definitely need a MOSFET. What else do we need? Let me get that MOSFET out of circuit where it's easier to check. The Zener, by the way, was bad. That little Zener diode, it was shorted, so good thing we replaced that. Let me see. Turn off the power. Well, we will discharge the capacitor. Not really anything left on it. I think I discharged it pretty well when that MOSFET went poof. Yeah, we'll get that MOSFET. I haven't even bothered cleaning it, you can tell. Let me get that MOSFET out. So let's look at this MOSFET under the microscope. And yeah, you can kind of see it looks like where it has arced between those two legs. I'm sorry, make sure it's in the shot. You see it right in there? Huh. So I'm not sure if there was something left behind by a roach that arced, but I don't trust this MOSFET anymore. We're going to replace it. Alright, I have replaced that MOSFET. I did go back and check that Zener that I had changed earlier, and it's still fine. The resistor, the fusible resistor there, the 0.16 ohm, is still fine. So I think either the MOSFET was either bad, or there's something, you know, left behind from roaches that's conductive between those two legs, and we don't need any of that going on. So I've changed it out, and let's get some AC power back in. It's not on right now. Let's see. My meter set up. I think we're ready to apply power to this again, and hopefully have a slightly less amount of fireworks. All right. What am I forgetting? Okay. AC power on. It's turned all the way to 0 right now. So I'm going to bring it up slowly. There we go. 4.8. Okay. No sparking or smoking that time. All right, I'm going to bring this on up to 120. Let's just go ahead and check our 12 volts while we're here. I do have it hooked to a load, and I think I've got, I can't remember, like 6 amps dialed in or something. Let's see. Standby. There we are, 11.83. Yes, 6 amps. We're drawing 6 amps of current. So, other than needing a deep cleaning, I think our supply is finally fixed. Okay. I'm going to do a good bit of cleanup on it, and on the board and on these nasty case parts. And we'll try it all together out there in the garage once it's all cleaned up and ready to be put back together. All right, we are back out in the garage. I have thoroughly cleaned this thing and have it reassembled. Cleaned up reasonably nice. It's got a lot of scratches on it, you know, fine scratches, but it cleaned up pretty good. Replaced that little, you know, button, the switch back here behind this, so because that was totally busted off. Our repaired power supply is in there. Our monitor's on. Let's see what happens. Okay, should work. We saw it work earlier with the standby, you know, supply, or my test supply there. Yep, there we are. Okay. I think this one's going to be all right. I cleaned it up as best I could. It's pretty clean in there. I think she's ready to go. I did get a GTA 5 disc out of the deal, which I didn't really need another one of those. I have plenty of them. But, yep, there we are. Well, I hope that was somewhat interesting and entertaining. If it was, please give me a thumbs up, and I will see you in the very next repair. So long for now.